Hello, and welcome to this yet another deep dive session on Istio. And myself, Kamish, coming back live after some time. It's good to see you all again. Still, we are reeling under the typical pandemic stuff. I hope to see you all soon live somewhere, at least later this year or at least early 2022. So, and with that, so I will also put some logistics. I'll be watching the chat and then doing the sessions as well, the little logistics before we get started. So what I'm going to put you on the chat is going to be the tutorial. As you see on the thing, it's that https dn.dev/SEO tutorial. uh, this is a tutorial which you can use. Hello, Mohammed. Good to see you again. I'll also be watching the chat. Please pop in the questions as we go on the chat. We'll take a break in between and try to answer the questions. Otherwise, we can take the questions at the end of the session as well. So we have some good demos to show for you guys to play with, interact with, and finally some more demos for me to show. And obviously, there might be technical glitches which I observed with YouTube and Google today. So in case if you miss me, don't worry, I'll come back, I'll log in again, and then so that you can continue the session. I hope nothing happens, but just a word of caution, right? So that's great. So what we will start with is on Istio today, right? So and obviously most of you know about me, so I'm just going to skip my intro slide. For people, somebody is new. So this is what I do at Red Hat. I'm a technology evangelist at Red Hat, actively evangelizing on serverless, service mesh, everything on OpenShift. Being an active open source contributor for more than a decade now to make one of these projects like Tecton CD, Minikube, Eclipse J, and Camel K. And also I have released my book last year on Knative. I'm planning for the version 2 of that book this year. Hope it gets out soon. If you have any questions on this session or anything related to serverless, service mesh, OpenShift for that matter, you can obviously reach out to me on my social handles. They are there on the chat and my email ID, my LinkedIn, my Twitter, and GitHub profile. I put on this thing. I'll also put them on the chat at the end of the session so that you can also reach out to me with any of your questions on those channels as well. All right. So with that, so what let's do is so why are we getting into service mesh? Okay, let's get the things a little bit interesting, right? Before I explain these stuff to you, right, what we are going to see today, so I want you to get onto your machines to play a small it's not a game basically, but I want you to open up this URL which I'm going to put on the chat. Let me copy that URL from my clipboard. I'm just going to say copy, and you should see that right there on the chat. So let me know once you are able to see them. Probably that's where we'll get started. While we do that, so let me also go back to my thing and stop sharing my slides, and let me get to my browser window. So where I'm on an OpenShift console, and then go start few things. So while you guys get the chat on the link, I'm just going to start up few things behind the scenes. Okay, just let me go here and start these parts. Excuse me, as I told you, like there is a slight delay. I don't know why. So I'm just going to start up these parts for us to play with. So this is going to be an interactive. So if you guys are able to access the URL, obviously you might get 404. Let me tell you when you can access that. I'll do it together with you. So let me do this. Let me also start all the parts so that we can get in action. All right. That's great. So let me put this window on this side, and I'll have all of the things on this side as well. Okay, I'm just going to pull out my terminal as well because I'm going to use some of them here. Okay, so let me do a little bit of rearrangement on my screen. Okay, so just vote it out. Like if you're able to, if you have any audio issues, any video issues, please call out on the chat. As well as you can also let me know once you're able to see the screen. Blue green. Okay, I'm just going to say this one. Okay, let me watch the chat to see if there is any thing on the chat. The URL is just posted, so I just post on the chat again. So you should also see it again on the screen right now. You should see a blue green flipping ones between these two. I'm having two browsers here just to show a few demos which you have slated for later down the time. So you should see one more here. Okay, so I have a Safari browser, I have a Firefox browser. So can you just open the URL and just let me know if you're able to see them? Just like what you see on my screen, the blue green flipping up and down. So let me know if you're able to see that. I'll wait for the information on the chat to see if you're able to see that. Austin, you're able to get a chat. Uh, okay, so Bitly link is not popping up. Okay, so shall I? I'm just going to show the URL on the chat. I mean, on my uh, screen itself, so that you can know the Bitly link. I don't know why I'm not able to post it. Can you try posting the URL again on the chat, please, if you don't mind? Uh, http://bitly.com, so that they can access it. Probably I might not have an access to post. Can you post the URL on the chat? Yes, I think Satish, I think you can find the URL here on my screen. If you're seeing my screen, the first URL is the one bit.ly/bgc demo 2. That's the URL. Okay, there goes the link. You can just click the link to see if you're seeing something like what I see on my screen right here. Okay, I'll wait for a few seconds for everybody to get onto this, and then let's start playing something. I hope everyone is able to get it. You can open in Firefox. You can open it up in a mobile browser. You can open up in Safari or Chrome, anything you wish to. Okay. Um, okay. So I think everyone got the URL. So let's do one thing. So I'm just going to start with deploying the very first thing. What I'm doing right now, I have three different versions of the service right now running in production. So if I have to go show this thing to you, so this is what you see on the screen on the topology view. So you'll be seeing all the three things running up for you as you see, right? When kind of saying popping up, these are popping up, the blue, green, and canary colors. They're respectively, canary is yellow, blue is blue, and green is green, right? So these are the three things which is popping up for you right now on the screen. Okay. So now the URL Sonam, I think the URL is again here, bit.ly bgc demo. Oh my gosh, the bit.ly link doesn't work in Bangladesh. I'm sorry about that, Mohammed. So let me get the URL for you, the full URL. That should be, if the bit.ly doesn't work, so try this URL where bit.ly doesn't work. I think, Mohammed, like if bit.ly doesn't work for you in Bangladesh, just try the second URL which I put here, right? It's a pretty long URL. That's the reason why I made this as bit.ly. I'll ask Tanya to post this back on the chat as well. Yeah, that's the one. I think, Tanya, if you can post that URL on the chat, that will be good. I think, great. Awesome. So I think, Mohammed, while you guys get onto this, so the one thing I want to show you right now is, so we are right now shifting the traffic between three different versions of the same service. I call this as blue, green, canary. So it's going to be blue, it's going to be green, it's going to be canary, right? So what we're going to do right now is just to go play with it live, right? So what I'm going to do right now, so I'm going to shift all the traffic, irrespective of which user agent you're using, into blue. That's what I'm first going to do. I'm just going to say, let's try all the traffic table. I have a script which basically does that work. It's not a big deal. Just some kubectl apply behind the scenes. So, and you should see that this traffic now gets into blue soon. Okay. Let me give some time. Okay. So now what happens, like every traffic, like okay, OCPNV. Okay, I'm on a different project. I'm sorry. Project BGC demo. Okay, I need to change my project. Unfortunately, I was on a different project, so that's the reason why I got the error. So I should be good now. Great. So now the blue-green candy is replaced. If you see right now, even the browser handles which you're doing right now, you should see them flipping everything to blue, right? Because I'm just doing a live change. I also wanted to maintain just, I'll just push this up so that you know the services are not pre-deployed. The services are still live, up and running for you. But we are on two different user agents. People are changing this one, right? Okay, now you should start to see blue color coming up for you. I think hope everybody who's on whatever browser you're on, you should be seeing them right there. Okay, let's try doing a little bit more stuff. Let's try doing green for that matter. Okay, so let's do a green, move everything to green. So now all the traffic across all the browsers, mobile devices, anything is now going to change to green. Okay, so this is one thing. What you're trying to do is like I'm applying Istio rules behind the scenes. You'll talk about that as part of this session, but I'm just giving you a glimpse of what we can do with Istio, right? Everything is software based, nothing is hardware based. No traffic splitting behind your hardware routers. Everything is done at software level. Okay, so and now like I'm just going to see everything to canary. So let's move everything to canary, all yellow right now. Okay, so now your traffic should change everything to yellow. So everybody is on yellow right now. Okay, um, so everything is good now. I think we went to blue, we went to green, and we went to candy right now, right? So we'll just play a little bit more. So what I'm going to do right now, if you are on a Firefox browser, if anybody is on a Firefox browser, now the Firefox is going to get this thing. Only Firefox is going to get it yellow. Rest of all others are going to be on blue. Okay. So let's see what happens right now. I'm applying the rules. Everybody gets on to green, but Firefox is the only one that's on yellow. Okay. So if you see this one, we are on green on everybody, like your Safari, your mobile browsers, everybody is going to be on green, and now everybody is going to convert on yellow. Okay. So let's do a little bit more stuff here. So what I'm going to do is I'm just open the developer tools, and then shift it to what you call a mobile browser. Okay, a mobile user agent. The mobile user agent is also in green right now because only Firefox browser was changed to yellow, right? So this is we are playing with the user agents right now. So what I'm going to do right now is I'm going to change it to Galaxy, which is an Android phone, and now we'll make sure that only Android users change to yellow. Okay, 11 Android. So all the other users are now basically going to remain on green itself. Now what I'm going to do right now is just change. Now you see that only Android users change it. Now if you're on a Firefox browser as such, desktop browser, you'll not see that. Let's go back here and see again, right? So let's go here and then flip it from this to what I say iPad. Okay, the iPad is green. Okay, so because only a Firefox browser, I'm just saying only for Android, I'll be on yellow, right? I'm just going to do the same thing here. When I shift Android, the Android agents gets in yellow, right? And these are all software rules for that matter, right? I'm plus playing with my virtual services here, service rules behind Kubernetes is going to take care of that. And you see the things changing just on the fly. I'm just applying the rules on the left side of the screen, and you see things happening on live, right? That's a speed at which things are changing, which the Istio does it so easily. All right, and let's go back here and then do one little thing. Let's change this to iPhone, okay, for that matter. So iPhone is still on green. So now I'm going to say iPhone. And then now what's going to happen is the iPhone users are going to flip to the new colors, right? The candy one. In a second, you should see iPhone changing out to candy, right? So only iPhone will be in candy right now. All of the users are going to be in thing, right? If you say into Galaxy, the Galaxy is going to be this. Obviously, iPad will be coming in, if I think so. I think iPad is also in thing. I'm just going to do only for iPhone. So which is going to change to yellow right now. Okay, Safari is still there, everybody is still there. Okay, this is a kind of thing which you play with everything. Right now what we'll do is one last thing before we get to the concepts is that for everything we'll change it to a green, right? I'm just going to go for all mobile user agent irrespective of its iPad, iPhone, other than the desktop browsers. Everybody is now going to change to what I call as blue color, right? This is going to be blue, everybody is going to be green. I'm on iPhone. Let me shift to what do you call Galaxy here. You should also be in thing because it's for every mobile. Let's see for tablets. Again, tablet is also there, right? So and then but the browser agents are still in green, so we are just making the browser agents still in green, so everybody's now we have three different. So this is one of the ways by which we can achieve in the microservices world, right? If we want to roll out features like blue green, or we call as toggle switching or all kind of things, right? All these things can be done at one little software called as Istio. At Istio we can achieve all these things just basing applying software rules. Okay, these are all Kubernetes YAMLs behind the scenes. We'll talk more about that in the architecture and other stuff on the concepts of Istio. But this is the whole concept. If I want to get these things cleaned up, I'm just going to say deploy a gateway. I'm just resetting every stuff right now, and we should be back to our blue green country for all the services, all the clients for that matter. So just flip to blue green country for all the clients, browser, iPhone, iPad, mobile, every devices are going to be there. Okay. I hope I'll just pause here to see if there's any questions while I shift to my the other demo namespace, so that like it's ready, so that I don't miss anything right now. Tutorial. Okay. Any questions until now? I'll take a few seconds to see if there's any questions on the chat before we can move on to the concepts. What was running behind the scenes for all these stuff? You can pop the questions on the chat. I hope there is no questions. If there's no questions, then what you'll do is let's go back to the presentation. I'm just going to close these ones for now, and then I'll shift it to a different namespace. Okay, tutorial. Right, and let's get to the presentation now. Let me go here to my presentation and then start the slideshow. Okay. I hope you should start to see my screen right now in a few seconds. Sorry about the little glitch in loading. Okay. I hope everybody sees my screen. I don't see any questions. Were everybody able to see all the part of the demo while the screen loads? Okay. Great. So let's get back to the concepts, right? So what was running behind the scenes is, right? So when we move from old school monolithic kind of architectures, right, where we have a single application that was running here, like as you see on my screen. Sorry, that was a little flip. So we all started to move to what is a microservices thing in today's world, right? So we all started to move from old school way of monolithic into microservices, and your application got distributed, right? And we use platforms like OpenShift and Kubernetes to kind of have these distribution done across cloud and across data centers, right? So, but the problem, what we started to see once you start to distribute, right, distribute application, is that when you start to do microservices, the application gets distributed. And once gets to distributed, the problem is you start to get to the fallacies of distributed computing. Okay, the network is not reliable. I'll be having latency. I'll be having some bandwidth issues. Okay, there's a few other things which will always be there. Right? That's already, you have to start to know these problems are there always. Okay, that should be in your mind when you start developing microservices. So which means that when something fails at this end, like what you see as the X mark, when some service fails on a distributed network, it's going to be a cascading failure, right, of the services that to the consumer, right? When something fails at the end of your service, I have a 10 services chain, and when something fails in between at fifth service, then it's going to be a cascading failure. I'll go back to the first service, right? So what it basically means that I should also have a way by which I should know to isolate the failure. Okay, we have these patterns like circuit breakers and other stuff, like which basically helps you to do this isolation of failures, right, and keep them out, right? And Istio does it well, as I'll talk more about that in a few seconds. So now once you do the isolation of failure, it's all possible for you to avoid the failures, so that you can choose a different path, so that your service goes to other ones as well. Okay. And also, like, if there's a temporary glitch, we can change the path. You can use it as you saw right now, right? So what we did is, like, everybody was on blue, green, and canary. Let's assume that in the same example which you saw right now, just all the mobile users, they are having some glitch, okay, towards going to a particular service, screen service for that matter. So what we did behind the scenes, we just changed the rules. What happened? Everybody started to flip to hello, right? So which will be in a different node on Kubernetes, so that's easy for you to get these things. Okay, that's something which you also see as a temporary glitch, right? There is a temporary glitch. We can shift the user traffic to a different set of services or another V2 of the services, so your service is not disrupted. Okay. So, but what basically happens when you want to cover all these things, when you want to take everything together and then bring up and build a service, right? So your service should exhibit set of properties. For example, an API, right? How to discover a service? I gave you an URL. You're accessing the URL, it's throwing you an API, and what I'm playing behind the scenes is a kind of I'm going to play with the APIs. Okay, I should have a discovery mechanism, and then I should also know how to invoke these services. Okay, and elasticity, resilience, these are all common things. Authentication, these are more little bit more enterprise stuff, which basically gets into the play, right, when you actually start to develop microservices. So when you develop microservices, you also should always keep in mind that my microservices should always exhibit these properties to be called it as a microservice. And when it's done this way, then we see that we are be able to in a good position to handle the fallacies of network computing. Whatever we saw, right? Circuit breakers, something is failing in between, my service is not reliable, I want to introduce a new feature which should not be for everyone, for only for some set of users, so that I know to get the feedback from the users and they can just start improving my application. And that's how big companies like Amazon and all of the people are doing. Like you see, they roll out into production, hundreds of deployments into production a day. Okay, but how does my platform is going to help, right? So which means that what was happening before, right, I'm just taking a Java example in this case, is that when I discover the microservices and when I have these kind of properties to be embedded within my microservices started to bloat. Okay, for example, my microservice has to encompass the discovery mechanism, the load balancer mechanism, resiliency, metrics, tracing, right? Everything has to be put in this so that my application is typically a good microservice which can be deployed and distributed. But eventually, if you think for a second, right, this is not something which is business related stuff. These are more ops related stuff, right? More infra related stuff. What I was trying to do is like I was dumping everything within my service. My service is basically a business application. Now we are mixing business with infrastructure thing together when you are developing microservice this way. Okay. Simple reason, Netflix was the only guy who started with all these distributed kind of stuff early before, and then we started to use Netflix OSS components, which are all Java based. But eventually, in today's world, we're trying to deploy applications which are both Java and not Java, and also like it could be like polyglot set of applications. The microservices are typically polyglot, all right? And then that's the reason why you use platforms like OpenShift and Kubernetes to containerize them and deploy them so that you can use APIs to talk to them, all right? But how does these complement, right? How does these platforms complement you to your microservice abilities, right? So if you see them, so by default, Kubernetes gives you the discovery mechanism, API, and invocation. So I don't need a separate library like Netflix OSS to sit inside my infrastructure to do me all these things, which I was doing earlier, right? And also, like if you see OpenShift brings you all the enterprise ready features, including authentication. Probably the authentication thing is also there, and tracing as well, right? So this brings all the things as well, right? So raw Kubernetes, upstream Kubernetes, more like a developer, dev-friendly dev kind of stuff. And we all get these things into OpenShift, giving enterprise features. In a way, we can also call OpenShift as an enterprise Kubernetes, right? Making things ready to run in an enterprise in a production grade, all right? But what was Istio doing for you, right? So Istio was basically complementing these services. As you imagine earlier, right? So Istio is not something which is new to be deployed. Istio is going to complement your existing OpenShift or Kubernetes deployments. In that way, if I imagine for a second, I could say, okay, I'm not going to get a new platform for you. It's a set of platforms is going to be deployed. I'll show that on an OpenShift console how Istio runs in a second. But if you think for a moment, what basically we are doing right here is that we are making discovery, we are making enhancing discovery mechanism, we are adding tracing to it, we're adding monitoring to it. We'll see all those things through demos in a few seconds. So this is what Istio does for. Istio is a bit of software components, right, which is getting deployed. Tomorrow, if you don't like Istio, I can take it out, just go to kubectl delete -f, and then Istio is gone from your cluster, right? That's all I need to do, right? It's not a very complex installation. Your application start to behave normally as it was before. Okay. So this is what Istio does. So Istio, just bear it in mind, Istio doesn't take away or add anything new. It's going to complement the functionalities that Kubernetes and OpenShift is already giving it for you. All right. So which means that, so before Istio, this is what we saw before Istio, right? Istio was, we are trying to load everything into this particular stuff, and it was kind of like all service was bloated. But what happens after Istio, right? I'm going to punch in something called as a sidecar. Okay, this is a new pattern. I have a links on the resources for the slides. Once you get the slide decks, you can read about the sidecar pattern, which means that the same Kubernetes pod is going to run two containers. So one is your actual application container. Another one is going to be a sidecar. Sidecar is going to be where Istio component is going to be deployed, the Envoy proxy, and that's what is going to run there. Okay. So which means that if you see the before and after, right? This is before what we had. Before Istio, your microservices look so bigger and fatter, right? And now what we have done, we have slimmed down the microservices by introducing a sidecar container, which is going to offload all your infrastructure things which was required, like a discovery, load balancing, circuit breaking, all the microservice properties, right? Which will be using multiple set of libraries, usually Java-based libraries, and then we remove all them up and then put them in a sidecar via Istio, and Istio is offloading them for you. So which means my service can, with the microservice right now, can concentrate only on what it needs to do. Okay. For a matter, when I was doing this exercise earlier, right? If you imagine, so what basically happened is like I wrote a simple hello world program um, using a Spring Boot controller or any kind of Java framework. That particular application was having around 75 lines of code. Okay, 75 lines of code just to say hello. If I want everything inside that, discovery, load balancer, resiliency, metrics, tracing, if I want to have everything inside that, that particular service was kind of having 75 lines of code. Like you'll be laughing right now, because for just writing system.out.println, uh, system.out.println, so what basically happens is that, so you just need to write 75 lines of code. Okay, so let me try to see. There is my image is frozen, so maybe like I'll try to turn off my camera just to see if that helps. I say like let me turn off my stop cam. Okay, I'm just turning off my camera just to save some bandwidth. So I hope like is okay with everyone. So from this, so that you can concentrate on the stuff, right? So what I was telling earlier, right? I was when I was writing a simple hello world application, but then I was writing 75 lines of code just to write a hello world, which is having all the other microservice properties like load balancing, discovery, and everything. Okay, but this is what the problem we are trying to solve with Istio, right? I'm just trying to say, okay, you don't need to do all those things, right? You don't need to do discovery, you don't need to do load balancing, you don't need to do anything else. I will take care of those things. Just have Istio deployed within a cluster, and then have an Istio sidecar injected into your application, right? That gets automatically done. When you're on platforms like Istio, we have automatic sidecar injection. You don't even need to do anything. I just need to tell, okay, this namespace is ready for Istio, right? That's all I need to do. And every pod within the namespace have the sidecar automatically injected as well. So there was a question. I'm just taking a pause to answer the question. Preetham was asking, as there will be involvement of sidecar containers additionally with the pods. Actually, Preetham, I think there will be a slide overhead 100%. I don't deny that. But the Envoy proxy sidecar, which I'll be explaining in a second, is super fast. Okay, it's based on C++ 14, if I remember correctly, and it's very fast and occupies very less resource, kind of something like 10 megabytes or something. So which means that there is an overhead. Obviously, there will be a hop because everything has to go through. I'll explain that in architecture in a second. But technically speaking, there will be an overhead, but there's always a trade-off, right? What you want to achieve and what's there, right? But I don't deny it. But as of today, I did not see any performance issues. So it's not a daemon set, it's set of a pod. Like we use a concept called as mutating webhook. So which means that when a pod is deployed and the sidecar is injected, it'll see for some annotations on the pod. The moment it sees the annotations, Kubernetes goes back and injects few stuff inside the pod. That's what is called as mutating webhook. I'll put the link on the chat later about mutating webhook. You can read about that. Istio uses that to kind of inject those things. It's not a daemon set. Okay, so let's get back to thing. You keep popping the questions. Thanks for those beautiful questions. We'll just move ahead. We'll talk more about that at the end of the session once we come to the end. So this is what we saw after Istio. This is what we said. Everything. Now, if you see for a second here, none of the service A, service B, and service B talks to them directly. So everything has to go through the sidecar container. That's where we apply all those rules, right? Your discovery, ACLs. We'll see them more about tracing and then rules, MTLS, and all these stuff, right? Which can talk to what and ACL, egress traffic control, ingress traffic control, everything. So everything we apply, we write rules for them, apply those rules inside a cluster on Istio so that the service goes through sidecar container. The sidecar container will check to see if that particular service is there or not, if the rules is apply, and then goes to the service B or B or C. So the pod will restart while putting the sidecar 100%, but it will happen even before the pod has started to serve your request. So you will not see that. From the end point of view, it's negligible. You don't see that at all. Okay. So this is what we do. We do Envoy sidecar. We can go Google about Envoy, read more Envoy, because Envoy is one of the fastest HTTP proxy that is available right now. We use that inside this so that like there is a very minimal impact of resources when you use sidecars. All right, great. So what you're trying to achieve right now is trying to get to the next generation of microservices and service mesh kind of stuff, right? It's going to be intelligent routing and load balancing. You'll see some of the examples. We already saw those examples, right? When we're doing with the earlier demo which I showed you, I applied rules. We are changing from mobile to iPad to Safari to Firefox. We have been doing all those kind of intelligent routing. We'll see about dark launches as a part of another demo, which I'm going to show you. Chaos engineering is going to be fault injection. I can do that also. These are all what I'm showing right now is next generation of microservices that you can write by just using rules. Your application is not going to change in any way. Your application code is still going to remain as a microservice. Only thing is you're going to move out all the infra pieces which you talked about earlier and making your application just do your business. It doesn't do anything more than that. Okay. We can also achieve resiliency via circuit breakers and then observability and telemetry. We'll see about that in tracing. So we'll not be seeing about all these things as part of today's demo. Maybe I think we just have, let's say I think we have 1 more hour if I'm not wrong. Okay. We'll try to see how much we can see. And also and then we'll see about security, encryption as well, and then fleet-wide policy enforcement. These 2 things are very important when you go to a big enterprise where your encryption authorization between your service important, like especially in financial services, where I say, okay, locking from pod A to pod B within my infrastructure also need to go to be encrypted traffic. So that is something which you can achieve. And fleet-wide policy enforcement, say I can apply rules at the entire cluster level, okay, and also at service level as well. And I saw a couple of more questions. What's the difference between Istio and Envoy? Istio is a complete framework. It's a service mesh that gives you this. Envoy is just a sidecar, okay, the HTTP sidecar that actually that is used by Istio to perform all these microservice architecture thing. See, I think like SSL communication happening on sidecar pod level. What will be the communication between the sidecar to the application pods? When the sidecar is there, it's pretty much like what I call the sidecar part of the pods is like a local host for it. The application pod is local host to this, so which means that the communication between them is always non-HTTP. Non-HTTPS. Okay, only when it goes out from the service, that's going to be HTTPS. Okay, so what I mean by this, in the same diagram, if you see to answer Ilayaraja's question here, the service A, when sidecar is talking to service A or sidecar is talking to service B, it's always going to be within the same container. They can do local host calls, okay, because these pods reside these 2 containers reside in the same pod. The moment that all the rules like MTLS or encryption or all of the stuff will come into picture only when I jump from service A want to talk to service B. Okay, that's where it goes through sidecar, and sidecar encrypts the traffic and send it to this particular guy using Istio rules. Okay, that's great. So all the exercise, I'm going to show you some demos. I'll be running some commands. Please don't worry if you're not able to grab the command immediately, because all these commands are part of this tutorial, dn.dev/istio-tutorial. So you can go try all these commands by yourself. So don't worry if you're going to miss it. If you have questions, as I told already, you can ping me back, drop me an email, or you can also open up an issue on the tutorial GitHub repository. I'll show you that in a second, so that like we will be able to answer the questions. Either me or somebody from the team can answer your questions as well. Okay. All right. So this is not the end. So that's end of my slides. So I'm just going to show you a few stuff. Let me go to my stuff here. All right. So as I was saying to you, I'm just going to is it Amit was asking a question. Let me check the question. Is it mandatory to have Istio Service Mesh in a mic? No, it's not mandatory. Amit, for doing microservices, it's not mandatory at all to have Istio. But if you want to do the things which we just saw, right? I want to have enhanced discovery. I want to have enhanced circuit breaking capabilities. I want to make myself little bit safe from the network fallacies, right? In case of those things, that's where I need to start using Istio. Okay. So let's see how you install Istio, right? I'm just going to start with that. I'm on an OpenShift environment. If you're not on OpenShift environment, there are multiple ways to get OpenShift environment for you. Okay. The very first way is that you can go to https try.openshift.com. Okay. I'm just putting the link on the chat. Want to get an OpenShift cluster for yourself, you can just do https try.openshift.com. That's going to get you to that particular site. Okay, so you can also, I think the link will be posted in the chat soon. But if you already have an Azure account, or if you already have what you call AWS account, then what we can basically do is, like, there is a managed OpenShift offering that is available, so which you can use, which helps you to get started very quickly. Okay, so I'm just putting these things also on the chat. You can also get the managed OpenShift stuff to get a cluster quick in fraction of seconds. You can use the ones which is right now there on Amazon as well as on Azure. If you have all Azure account or Amazon account, it's pretty easy for you to get. If it's there in IBM Cloud as well, as part of what we call as ROCs, you can just go to IBM Cloud. If you have IBM Cloud, they can just go get it from IBM Cloud as well. Okay. I'm putting all those things on the chat, and then so that like you can get those links as well. These links will be posted on the chat for you. So I think before we get well deep into the details, Ashish and Vijesh, I'll come back to your questions in a second. Before that, I want to show how Istios get installed, right? Assume that you have OpenShift already with you, okay? When you're on OpenShift, I'm just going to go to the namespace called as Istio namespace. Keep popping the questions. I'll come back to the questions in a second. So you can use something called as operator hub that is available in OpenShift that can be used to go and install software on OpenShift. Okay. So in this case, I'm just going to use an operator hub. And then if I go see the install operators, I'll have a bunch of operators installed. I have Elasticsearch, Jaeger for tracing, Kiali. You'll see all about them in a short moment. So and then Red Hat OpenShift Service Mesh, which is nothing but the supported version of Istio by Red Hat. Okay. So all these things you can get from the operator hub. So operator hub is a central hub for all the softwares that you can install on Kubernetes. In this case, in OpenShift, and it also there are some Red Hat certified community operators, Red Hat certified operators. Everything is there so that you can go install them at one click. Okay. For example, if you want to install Service Mesh, I'll go search Service Mesh from here. Okay. Uh, Service Mesh, for example, let me go find if I'm going to get Service Mesh here. Okay. I'm just typing Service Mesh to see if okay, I already have installed, so it's marked as installed right now, but otherwise you'll be getting an install button here. You can follow the steps. It gets your Service Mesh installed on your OpenShift cluster. Okay, so this is so easy for you to install. There is no big hard thing. And as I told you earlier, it's a bunch of software components that is residing within a cluster, which means that I have a namespace, which is nothing but your project in OpenShift Earl. And also I have a bunch of pods which is running right now. You see this, I have a Grafana, I have STOD, egress gateway, ingress gateway. You have a lot of other technical components, infrastructure components of Istio that is running there within your cluster. Okay. So with this, what we can also do is, like, we can install these components here. And then if you don't want Istio to be there, just go delete the namespace. Everything is gone. All right. So this is so easy to get it installed. So, and also, like as I told you earlier, you can also get an OpenShift cluster from these links which I posted on the chat. I'm just posting the thing again while I answer the question. Um A lot of questions right now. Amit, I think I answered your question. Can you perform sidecar action on existing work pods? Um, yes, we can do on any pod for that matter, Ashish. Like, it's not that there is no picking and forcing, but for also we can also do one without do also. For example, in the same namespace, I can have pods with particular which is running using service mesh, and can have pods without using service mesh. Both are possible. Okay, there is annotation that I need to say don't inject it. It will not inject that. Okay, so that's one. And then okay, so Vijush, I think that's a bigger Istio versus Linkerd. That's a big talk assess. The performance and the community that's backing Istio used Envoy proxy, and over all the multiple other reasons, performance and the support thing which is being given. So that itself is a separate talk. Probably I can point you to some good links if you can drop me a note offline to see the exact difference between these two versions of what do you call the service meshes. Okay. Again, Linkerd is based on Java completely, whereas Istio is completely based on C++ and Golang. Okay, and there are other things in that. Like, I think probably if we start to discuss those things, it will eat up my complete session. Okay, and then the other question is regarding it will be, but I will post once we have covered this. Okay, that's great. Is there a competitors in market for Istio? There are a lot of competitors, Amit. I think, in fact, as you said, Linkerd is there. There's something called as traffic is there. There are a lot of competitors for Istio. But again, when it comes to Cube platform and other stuff, Istio is more trusted, and it's used a lot, and the big communities backing that as well. Okay. We understand that control plane and the data plane for Istio, whether both will be installed on the same space. Yes, everything is on same namespace. Right. So if you see, as you see on my screen right now, think like I have a bunch of pods is running here. So it covers all your control plane and data plane stuff. Okay. So you have Grafana, your HTOD, Ingress Gateway, Agar, Kiali, and Prometheus. So everything is there in one namespace called as Istio system. It's not distributed across namespace. That's the reason why I said when you want to knock off the things, it's all required. Just you go delete the Istio namespace, everything is gone. Okay. All right, so keep popping the questions. That's good to have all these questions. It's interesting discussions on this. So I'll go back to jump to my service demos to show you other pieces, right? So what I was saying to you is that this is the tutorial which you have. This is a GitHub repository if you want to know. So where you can go find the tutorial here. I put that thing on the resources. When you get the slides, this link is there as part of the resources. I'll also put these links at the end of the chat so that you can access these ones. You can also go find out, this is the HTML version of this one. Okay, so we have a simple 3 different microservices, and we're going to see a few things. I will not be able to show the complete stuff which is there. I'm not going to show security also because I've not set that up right now. So we'll see about observability. We'll see about basic traffic control. We saw something in the earlier. What we'll see right now is doing dark launches, mirroring traffic, retries, and all of the stuff. Right? We'll see about those things as well. As I told you earlier, so don't worry if you miss my commands. I have a scripted commands. So if you don't worry if you miss those commands, just remember the sections that you're talking about. You can just go try these things by yourself using a mini cube cluster. You don't even need to have OpenShift just to try this. But I'll recommend that you do OpenShift because that's where you know the power what OpenShift is bringing from enterprise point of view. Okay, for development purpose, fine. You can just go try it out on your mini cube or whatever thing, and then get these things installed and set up. The process is exactly same, no big difference. All right. So with that, so let's go and do some hacking. Okay. So let's go here. I'm just going to a developer perspective. So this is also another good thing about OpenShift is that we have 2 different perspectives for people who are working based on the personas. One is the developer perspective, and another one is the administrator perspective. So based on your role, you can choose which perspective we want to be, right? So that like you have less noise on the screen and concentrate only on what you want to do. Okay. So for the interest of time, what I did is like I did this first step of deploying of microservices already. I deployed all these microservices here. Customer preference and recommendation. There are 3 different services, and I have 2 versions of customer and recommendation. Sorry, 2 versions of recommendation, V1 and V2. Okay, what we are basically going to do is like customer is going to call preference is going to call recommendation. Okay, Why I said two things is because like what basically now is going to happen is, so once I click this, the customer will call preference. I'll change rules so that your application traffic will go behind the scenes. Okay, we'll also see the rules changes using Kali. So let me open the Kali while this happens. So this is the service mesh observability. I'll show you what it means in a second. So let's go here and okay, I have a Kiali, and then the Kiali is going to show you a graphical representation of my application namespace. Okay, so rather than seeing here, okay, so what we saw here is a whole the Kubernetes view of things, right? So what I'm showing right now with Kiali is more on the tutorial namespace. What I'm trying to show you, it also shows that it's on Istio system. So it shows you the whole distribution. I have customer, it shows you customer talks to preference, preference talks to two different versions of recommendation. Okay, we'll flip the traffic between those things as part of the demos. Okay, so what I'm also going to do, add a little bit of traffic animation to this so that you know how the traffic is moving. But right now there is no traffic here, so you'll be seeing everything in gray. But soon you're going to start a traffic, and you'll see that, and we'll come back to this to see how this is getting distributed. Okay. Any questions? Can you guide on OpenShift setup for installing the links which I posted on the try.openshift.com? I think I think since I don't have access, I'm requesting Tanya, or you want to post those links which I have on the chat right now to the public chat so that people can access these links. So the documentation talks to you about disconnected install as well, so you don't need to worry about that. Okay, so what I'm right now using is a public cloud. I'm on GCP cloud. You can have GCP, Azure, IBM, any cloud for that matter. So what you can also do is you can also have a disconnected install is also possible. So at the Amazon and Azure versions of OpenShift gets you much more faster, right? It's managed versions, which is managed by Red Hat for you. So you can just use those services and pay those services using your Azure billing or AWS billing. Okay, so that's kind of a managed services on that, right? So let's get into the crux. So what I'm going to do right now, let's go into the first exercise of this tutorial, right? So where I say that I'm going to deploy the service. Let me give a one call to the service. Okay, something like this. I can just go hit copy from here, and I'm going to go to my thing, right? So let me go here. Let me make this a little bit smaller. And let me make this to a bigger one. Okay. And I'm going to use my, I'll move this side so that like we can see both of them on the same side. Let me go to my Istio tutorial. Okay. So what I'm going to do right now, I'm just going to just give a call to the service, right? So let's be on Kali. So we don't need to actually see this. I'll walk you through again. So I'm on Kali. I'm going to hide this one so that you can see the stuff a little bit bigger. Okay. And also hide this one also. We'll come back to that in a second. So I'm just going to start the service here. Just give a curl. Okay, the service is not deployed. Okay, so I'm just going to say one scripts. The service gets deployed. I'm just going to see my scripts in this case. So ls. Okay. These are just scripted ones, just for my convenience. I'm just using the scripts and stuff, typing kubectl commands, and the streaming is kind of eating my CPU as well. Like it's bumped up to 98%. So that's the reason why you see slight lags on my, not slight, I should say, bigger lags on my thing, right? Okay, so I have the application deployed already. So I said one deploy. Okay, service gets deployed here, and then also creates a gateway and every other stuff so that my traffic starts flowing in. Okay, so while this service gets applied, so I'm just also going to go and do a little housekeeping for myself so that like I know this URL where I'm going. You see the services are getting deployed. That's the reason why you see this thing refreshed here to show you the changes. There's nothing changed because I already have things running for me. So all we require right now is to kind of, let me see if I have any questions while that thing happened. Okay. Uh, Everything is already there. I'm just making sure that I don't miss anything. So the services, everything is up there. The gateway is there. Everything is there. So I'll just do a curl of the gateway so that we can go from to preference to recommendation. Okay. All right. So let's kick off something here. So preference already exists. Everything is there. So nothing is changed. So all my recommendation V1 is there. V2 is there. I'm just ensuring everything is there. Okay. So the error reported is because the services are already there on the namespace. That's the reason you see these errors getting reported for you. So the services are already there. I'm just making sure that everything is there before I start on with the demos. Okay. So we have everything there. So let me do this to just going to start with observability piece. That's what you see here on the screen, right? We'll see about the Grafana dashboards in a second. But what I'm trying to do right now is just going to show you the Grafana dashboards for you. Okay, it shows you Kayali, it shows you Grafana dashboards. We already have all those things right now. It also opens up a Jaeger dashboards for you so that you can see the traffic flowing in there. Okay, so I just need to do it's SSO, so I have to just do a login. Okay, I just do a GitHub login here because I already have that connected with my OpenShift cluster. We already have Kali here. This is exactly the same Kali which you see here. So only thing is that I need to shift to the namespace, which is there. So you can just go to service graph. I'm already had the tutorial namespace here. Okay. And then, as I told you earlier, I'll hide these things. And let me display some animation for you. Okay. No, Simon, I think multi-cluster is not covered as part of this session. Okay. So let's do a curl. I'm just going to run a series of things. URL. Okay. Now the traffic is going from customer V1 and V2, and they should start to see the animation in a second. I'm just doing some load because for you to show the load and then how much service using Grafana dashboards, what all things you can do. There's a good book of Istio, which I have that on my thing. So we wrote a book and that's released as part of our the from Red Hat. It's free download. All the links are there as part of the Istio service deck, which you'll get later. Okay, the book links, everything is there. And now, as you see on my screen, the traffic is going from customer to preference, V1 to V2 alternatively. That's the reason you start to see the traffic animation on the screen, which shows you on how the traffic is getting distributed across these services, right? It's going from customer to V1, preference V1, because we have only one version of those two services, and then it gets distributed for you into V1 and V2, right? That's what you see here. And you also see every service is reporting back to Jaeger. That's where the traces gets collected. Okay, that's where we get the traces. For example, let's go see that one, right? So let's see what happens with some data, right? So I'm going to hide this one. So I don't know what's happening with my shit, right? So I can click on this. When I click on the service, I'll go to the service health. I can go find out the service health as well. Let me give some time. It's getting refreshed. I click on this. It goes to the service, and then I can see I can go to the service level to see the service traffic, right? How much traffic this guy is taking inside. Okay. And then I can just see the inbound metrics that also happens, whether this guy is healthy or not. And then I can also go to the thing here, how much inbound metrics this one is having, right? How much request volume is coming there. Because these are some things which you will not get without a service mesh there. Okay, these are something which is collected from the service and back to the Grafana dashboard that is done by Istio sidecar. Everything is done using the Istio sidecar here. All right. So now if I go to a Grafana dashboard here, it will show you even more detailed information about these services. Okay. For example, in this case, it's just going to show me about this particular service in this customer service alone. How much is the client volume? How many operations per second? What is the success rate? What is the failure rate? And you also see more of the all of the graph, right? These are all Grafana dashboards which already built in. The moment I install Istio, everything is there for you. So from a DevOps perspective, it's easy for you to go and observe this stuff. You don't need to do anything bigger for you to install other components, other tools, connect them together, make them talk with each other to do all this kind of stuff. All right, that's what Istio does it so easily for you just by installing Istio. I think I have seen people done that, but I don't have personal experience of using App Dynamics with Istio. So, but for my sake, like I already see that these all these things gives you more information for what I want. So, but I never tried, but I heard from people that it's doable. Okay, so you get all these things, and also like I can also see traces, right? Traces. What I mean by traces is that so it gives you like view tracing. If you click on view tracing, it's going to open a Jaeger thing for me. Okay, so tracing gives you like, for example, when I said when you talked about microservices, right? So what we basically said is that when a microservice goes from, let me click on this 11 spans for a second. So it gets distributed, and I go from service 1 to service 2 to service 3 to service 4, right? And then, for example, one of the service is getting slow. Your SLA is not getting achieved. Okay. For example, in this case, customer goes to preference goes to recommendation. Okay. Recommendation V1 or V2 in this case. And you should see how long this particular service is taking, right? 20.44 milliseconds is what the total time which is taken. Okay. And you should also get the distribution among each service call. Okay. Every little hop that happens, the trace is collected to see how long it's been spent here to from this service to this service to this service, another service. Okay. So this is super important when you are doing microservices, is because the moment I do all these things, okay, when I distribute my microservices, the biggest problem I get is that what will happen if something is slow. So how do I collect the data? So how do I know where to fix it? So you need to go get those details, right? That exactly what happens before this particular one. When you're going to use Jaeger, then Jaeger is going to show you all these tracing. So okay, I'm going to go service 3 talks to database. The database is not performing well. So let me go and fix it. So you can easily identify those bottlenecks and come back and start doing stuff. Okay, so that is a big advantage of all these things, right? When you put Istio in, I'm able to get the holistic view of all these things from one little namespace, right? So just one little Istio there, you're getting everything out there, including your traffic distribution. I'm getting these things into these ones as well. It doesn't reduce the performance. If you see this, that's what I'm trying to show from the screen. If you see this here, this is going to be a parallel call. This is an asynchronous call that's going to get into Jaeger. It's not a synchronous call. So which means that the tracer gets collect these things so easily. Okay. So this will not interrupt your actual service traffic. The actual service traffic is V1, V2 preference like thing. And if you see this line, which is going here, this is going to go direct call to Jaeger. That's going to be an asynchronous call, and it's super fast. Jaeger is amazingly fast, so you don't need to worry about that. Okay, good. So what you're done right now, we're distributing traffic to everything, right? So now I said I want to distribute traffic only to V1 of the service. Okay, I'm just going to stop this and then say only V1. All right. So let me go find how do I distribute. I'm just going to find my traffic distribution 3 here. I'm going to route all the traffic to V1 right now. So now keep observing the graph right now, what you see on my screen. Now the moment I change the traffic, I'm doing the same rules application right now. So what is basically do right now is going to divert all the traffic only to V1. The no traffic is now going to go to V2. So it will take a moment for the graph to refresh, but that's what we're trying to do. If you see this one earlier, we are doing customer preference recommendation V1, V2, but now you see all the traffic is just going to V1. Okay. Let me try refreshing this to see if you're able to see those change, but the change should be soon. The traffic, you should not see any traffic flowing to to V2. The V2 now should be grayed out for you. I think I'm not sure about the algorithm that's written behind the scenes on collection of your metrics. but technically it will do for all the traffic flow, right? Okay, so if you see on the screen right now, this traffic is blocked, right? Because I'm just applied the rules that says go only to v1, right? All the services right now going only to v1. That's the reason why you see the traffic is only going to v1, right? V2 is completely down right now. No traffic is going to v2. I'm just controlling them using Istio rules again. So these are all Istio rules. If you go to the tutorial, we talk about them in detail, or if you go to Istio sites, it gives you about these virtual services. These are again a set of YAMLs, Kubernetes YAMLs that we write to go and apply these rules. We in Kubernetes world we call them as CRDs. That's used to do this work. Okay, we go from v1 to v2 and then we just apply this one right now. Let's go to one more thing. Let's change the traffic back to, let's say, v2 alone. Okay, I'm just going to do a traffic distribution to v2. All right, so now the traffic, all the traffic now goes flips from v1 to v2 right now. Okay, my thing is wrong. Okay, I'm just going to split my traffic. What I'm going to do right now, since we have all V1 earlier, now I'm going to shift my traffic from V1 to V2. So now I'm going to stop traffic going to V1 and I'm going to make all the traffic go to V2. So that's what I'm going to do right now. It's just going to take all the traffic from V1 and push it to V2. Okay. So while this refresh happens, I think all these things are given here, right? If you go to the tutorial, if you go to the tutorial link here, so if you go, we saw about observability, we opened up Grafana dashboard. Kiali is one place from where we saw everything. So we're still seeing with Kiali for all the service mesh observability. We go to traffic control. That's where you see the simple routing, the routing which I'm explaining right now, right? The simple routing, and then the advanced routing is where we see the canary deployment, which you saw earlier. We'll see about mirroring traffic. That's a very interesting one to see. So we saw about the canary deployment earlier, right? When we did the first demo during the start of the session, we are splitting the traffic between multiple services like blue, green, canary, and all the stuff. Okay. So all these things which I did right now, the scripts which I wrote, all these things are covered here as part of this traffic control stuff. Okay. You can just go try this out by yourself as well. It's super easy. Okay. Just get a grab of fun. Now you see this traffic is blocked for V1. There's no traffic going to V1 and everything is going to V2 right now. Okay. And all I'm doing is just applying of rules, right? These are a bunch of YAMLs that I'm doing, as you saw already when I typed those shell scripts, just to save time, kubectl commands. Let me cat one of those things to see you, right? See this, these are just kubectl apply, right? And then I start pulling the things up. I'm not doing anything extra here, right? This is the power of Istio, right? You're not trying to create something new. It gives you a CRD which can plug into Kubernetes API to do all these tasks for you. So that's the thing of thing. Maybe like you need to write some configuration parameters and other stuff based on your environment, but that's what Istio is up. It's that level of easiness that comes to you when you want to split traffic, change traffic, and do all this stuff. Okay. See, another interesting stuff which you can also do with Istio is mirroring traffic. Okay, I'm not sure how many of you had heard about dark launches. Okay, so this is one concept which is behind the microservices world, right? So sometimes what might happen is that I want to test my application with the real-time traffic. Okay, the real-time traffic that is flowing into my site, so that I can adjust my application to do a few other things. Okay. So in those cases, what basically happens right now is that you cannot do that with the data, with the test data which you have, right? Because it will not be as same as your realistic data. So what we basically do with dark launches is basically we try to send a parallel traffic that gets inside the system. Okay. What I mean by this is that, just for a second, I'll take a second for you to observe what is right here. Okay. In this case, what basically happens is that the traffic is flowing from all the directions. You have V1 and V2 traffic, and the traffic is getting here, and then it's getting applied, and then it's kind of refreshing the traffic, V1 and V2 and every stuff that's happening here. I stop the traffic right now, so you don't see the traffic flowing in. So, but what we'll see there will be one more parallel line, or I should say a parallel traffic that gets fed inside your system. Okay, that's where you're going to collect the traces that you are going to use to kind of make changes to your application. This is what is called as dark launches. So you can go read about dark launches, more about dark launches. I think it's Facebook who started this one earlier. So, but you can also go read about that and then see what will happen to this. So let's go and do some dock launches here, right? So I'm just going to see traffic mirroring. The two. I'm just going to skip the that Safari Firefox one because we already saw that one earlier during this thing, right? So now when I go back to my Kiali thing, right? So let's go here. So it gets refreshed. I think I've just made it 10 seconds, but sometimes there will be a slight delay. So all the traffic is right now going to V1, right? There's no traffic is going to anything else. But you should also see one traffic directly going to Jaeger to collect traces. So this is what I meant by dark launches. Okay. So all the traffic is right now going to V1 apart from the other one, like the normal way, customer preference recommendation. But you also see the red one here, right? Which says that there is a traffic which is going from here during using dark launches. Okay. You can also open up the legend to see what's happening here. So you can just click on the legend to see what the color means, the color codes means, right? So it's kind of there is some failures is also happening here. Okay, and the traffic is kind of going from V1 to V2 and here as well. Okay, you can read about all these things here. We don't have a TLS badge, so you don't see TLS here. And then these are all services. We don't have circuit breaker. You'll apply a circuit breaker soon and see what will happen. Okay, so that's going to be some more of the exercises which you'll do as part of this demo. But I want you to observe the direct traffic which is going from here. Okay, it does not go to the service. It's not going to respond, but we are collecting the data and sending them to Jaeger tracing to find out the data which could be used for your application development. Okay, hide this one. Okay, I'm going to stop this mirroring. So this is what is dark launches. So this is very useful when you want to collect the actual data and find out what is going to happen to my application. Okay. I don't see any more questions. So what I'll do is I'll just do a small cleanup and then I'll try something about resilience in retries. Okay. So I think that should be pretty much I can do within the time I have. I have probably 10 more minutes before I close. So let's go and find out. We saw about. I'm just parallelly walking you through the tutorial as well, so that you can go find out which places we have been talking. We saw about mirroring traffic. Obviously, you know about load balancer. These are again a very simple concept. You can go find it out. Let's go to service resiliency, where I'm going to use retries. Okay, so let's do this. So let me go and do this one. I'm just going to use the retries first one. I'm just going to apply a retry rule here. So if you go to the Kali console, again, it opens up the Kali console for you. So there is a retry thing. So you'll see here, and let me close this one. Let's refresh this one, and then we will see a retry one here. So you see the error happening in this spot. That's exactly what it actually means to you. Okay, the traffic is going to V1. There is no traffic is going to V2 because we have a distribution of traffic. But on and off, you see the traffic to V2 is failing. So okay, so which means that the traffic to V2, but you will not see the failure coming back here because the application get distributed directly to this, and then you see this failure happening here. Your view also shows you that I'm going to retry it, and after some time it will try to retry, and the traffic goes through that. Okay, you'll also see those things as well happening here. So it's just going to bump here, go here. That's exactly what we do here. Okay, so we say it's to misbehave, so it's going to misbehaving for you. Okay, and you see this one, the V2 block as is shown on the screen. Exactly, that's what you see here. There is an error that's happening here. So let's go and correct this one. Okay, and see what happens to that. Okay, I'm going to correct the retries. I'm going to get it back to the normal mode. So I'm just going to fix it up. Okay, so let me stop this, and then you should start to see the traffic, because what basically happens is Ghost tries this particular service which is failing for few times, and it keeps this traffic out of that, and it sends the traffic to other things, which means that this is what we talk about isolation in the earlier part of the slides, right? Where you're isolating the service and you're starting to see the service as well. Okay, let me see 5.2, and this I'm going to fix this retries. Okay, so now basically what happens once the retries is fixed You should try to see this one. The traffic now gets back to the normalcy mode of getting distributed between these two things. Okay, so it'll distribute between traffic V1 and V2 automatically. So now it goes recommendation. It takes few seconds for it to distribute it. You see the traffic getting distributed between V1 and V2 already, but usually Kiali gets these data in intervals. So that's the reason why you don't see the refresh happening so fast. Okay, I just even made it 10. Okay, now you see uh, 10 seconds, but sometimes okay. Now the traffic, everybody's got to normal mode right now, because earlier you're getting an error on V2. Now we fix the error on the retries, so that now what happens, the error is gone. Okay, again, these are simulated ones, right? These are not actual errors. Okay, we try to simulate error on V2 pod and keeping there. Okay, so that's how it actually works. Now I fix this thing. So all these are rules, so you can go read more about these things in here in the resiliency, where we go and induce a resiliency and try to make these things happen. Okay, so now let's do a little bit on timeout. So these are all very important stuff, right? Retries, timeouts. These plays a very important role when you are kind of building microservices, right? Because you need to understand how your application should behave when something happens like this. Okay, that is one part of testing. Another one is also in a real production scenario, how my application should react when something happens like this. Okay, both of the things are considered here. That's the reason why Istio helps you to do them in production, as well as Istio also helps you to do test them during these kind of things using chaos testing and chaos engineering. Okay, so let's try a circuit breaker one. A circuit breaker in Istio is a little bit different, I'll tell you. Circuit breaker in Istio is basically like what you could say. It's not the actual. I should say. I should say in other word, it's like kind of a bulkhead. What I mean by that is like, let's say I have 10 pods. Okay, uh, that is running. That is balancing my recommendation service for this case. Okay, and out of those 10 pods, there is one pod. Let's say eighth pod or ninth pod is continuously failing. Okay, for some reason, maybe it might not have enough resources. The node might run out of resources or something like that. So what happens in this case is that this particular pod, what Istio does is takes this pod out of ejection. What I mean by that ejection is that by default, Kubernetes does a load balancing between all your pods, right? As part of your service load balancing. When I do a pod ejection or a pool ejection, what happens now? Kubernetes, I think it Istio does what it tends the load balancing only to all the other 9 pods and keep this one pod out for some time until it heals it back. So this is called as pool ejection. So you can read more about that in the Istio site. Again, the link is there on the resources. But let me explain that again. So it uses circuit breaker by a concept called as pool ejection. By pool ejection, what it does an enhancement to the load balancing that natively done by Kubernetes by keeping the failing pod out of your pool, so that the load balancing happens only between the active healthy good pods. Okay, that's what Istio does with respect to circuit breakers. Okay, let's try that. I think let's try resiliency with a little bit on timeout, and I'll come back to the other one later. Okay, so let's see what will happen when my service response slow. Okay, so I'll come back to service. I'm just going to do so resiliency in this case. What I'm trying to do is like, so let's say we saw retries. So now what if my service responds slow? What should I do now? Right? You should also be aware that when my service responds slow, I should also apply some logic behind the scenes so that my application behaves well, so that my clients, my SLA and everything are covered properly. Okay. So this is what we're trying to do with right now. We are going to make sure that V2 is going to load. Now the entire recommendation is going to V2. V2 is making it slow, as you see here. Okay. You see the red bar coming back. There is some problem happening with the service. That's what the indication does. So everything goes good. But what happens that the V2 service is a bit slow. Okay. That's what is getting indicated here as part of Kiali. So that's the power of Kiali, right? I can observe everything of from the Istio point of view, everything with one single window of Kiali. Okay. Earlier, when I used to do the demos earlier on, before Kiali was much better, many watts in early days of Kiali. So what basically happened, I have to kind of do all the things using command line. But now I reduce my command line. I just showing you for the service is running to induce a load. But what happens time on and off, you see the service will be slow. Okay. Now everything is good for some time. Now what happens is after some time, it will go again to slowness. Okay. That's what they're doing with the timeout. So thing which you're indicating behind the scenes, so the service becomes slow. And what happened at that time is that the other one is going to take care of the thing doing. Again, these are even covered by Istio for you, so you don't need to worry about what happens behind the scenes. All right. So this is with that respect to the resiliency of slowness. So you saw about slowing. I think again this is part of the tutorial here. Let me go back to tutorial. We have the timeouts here, talking more detail about what actually happening in timeout. So there'll also be pointers to the actual thing, right? So we are done with timeouts. We're done with all of the stuff. Let's go and do a little bit of circuit breaker because we are at top of the hour. So we go do. So some timeout is done, and then I just do talk about timeout for a second. So let's see what happens to timeout when service fails. Service is not responding. So let's go do that as well. So you can just observe the Kiali for this second. So nothing need to do there. This is just again a set of rules that is getting applied to induce timeout. Okay, this is again part of chaos engineering which you can do to induce a timeout to the service to see how my service is respond, what's the response my consumer is getting as well. Okay, so we'll wait for some as usual few seconds for Kiali to show us those changes. You see the service, you see the getting one in danger, and then that's getting cascaded all over to the customer service because the traffic is not going to going to V2 because V2 is kind of timing out for you. Okay, that's what we did as part of the script. So the V2 is timing out, so my application is not going to going to V2, it's just going to go to V1. Okay, now V1 is failing, getting timeout, so everything is going to V2. So it kind of does this kind of a balancing for you, so you don't need to worry about what actually happens here as part of this. That's the advantage of Istio behind the scenes. Istio rules does this thing, all these network related stuff, right? All the problems of microservice, all the problems that might come with distributed computing are all being taken care by service. Service mesh protects you from doing all those things. You can write the appropriate rules so that you are alleviated out of these problems. All right. So, and one last thing before we sign out is that I want to show you circuit breaker. Let me clean the stuff off. That's another interesting one, which a lot of people will be interested in. What will happen if my service fails? How do I respond? Okay, what will happen to that? Those circuit breaker concepts, which we just now talked about, right? Let's go and talk about without circuit breaker and with circuit breaker, right? Let's see what happens. So if you want to go read about that, so let's go here, getting back to tutorial. Okay, so if you go to kiosk testing, not kiosk testing, I think it should be circuit breakers, fail fast. Okay, so fail fast is one of the things which we need to do as part of microservices, right? In microservices, the concept says that when something fails, report immediately to the consumer. So that's the concept behind the scenes. Okay, so as part of these things, you will kind of first observe like how it's running, and the next we'll see what happens to the other one, right? Let me try to see if I'm able to run because I need a tool for this to run. Let me see if I have the tool on hand. Okay, let me go find this out. And you'll also, it will be nice for us to observe the legends, right? The legend for circuit breakers will be something like this. Okay, so let's go here. You should see a circuit breaker happening here. You should see this legend somewhere. Okay, so let's see if you are able to see the legend on the graph. Okay, so you have a service here. Okay, so you should see somewhere the service should fail. Okay, let's give some time for this to happen. I got tracing. Let's see if I'm able to get through that. I'm send some tracing data here. Circuit breaker works well. I think there's no circuit breaker. Let's introduce a circuit breaker. Okay, 57. We have 10 more minutes to go. I have few more resource slides to share, and then 5 more minutes back to you guys. Okay, let me see if this. Give me 1 second. I think just trying to kill the command here. I'm going to do the last one right now. The last demo for us. See what happens right now. I'm just starting a circuit breaker here. I'm just going to break a service in between. As I told you earlier, the circuit breaker in Istio is done using a concept called as spool ejection, where that particular pod will be cut out of the service load balancing. Okay, so let's see what happens. You see this one right now. You saw the circuit is breaking here. Okay, these breaks are here as you see right now because I've induced the circuit breaker here. The service are now breaking back. So because the things are not able to reach there, so obviously you'll be reporting fail back. Okay, that the service will report a failure back, so that like we can go back to your whatever the mitigation thing, right, that you need to do from the consumer side. So that's one of the things which you need to be important. But again, as I said earlier, so everything is shown from the observability point of view from Kayali. Okay, so you don't need to go, even it can validate your service mesh configurations as well with Istio. Okay, and then if you take any other normal Istio Service Mesh distribution, right? And this one, so we have integrated everything inside Kubernetes in the enterprise ready way. So it's easy for you to just install OpenShift, install Istio on top of it, and keep going. Okay, just concentrate on only on your business and nothing more than that. Okay, so let me see if this goes back. I think, as I said earlier, I can also validate the config. I actually I made something. If you see this one, this can also validate your configuration. It gives you something. There is some warning here saying that this configuration has some problems here. Okay, this is, I think it also gives you that more than one gateway at the same port combination, gives you a few other warnings like this. If something is broken, it will be showing a danger sign here so that you know, seeing this, what's happening, what's not happening. Okay, so as part of these scripts, as I told you earlier, I wrote a recommendation YAML. As you see here, this is just a YAML which is being wrote. Okay, and I can go edit these YAMLs as well. I can delete and do whatever you want. So this is the what you call a CRD, which is given by Istio, as you see here, destination rule CRD. That's what I've been using for all the demos so far. Okay, these are just destination rules which runs there, and then it has a traffic policy, outlier deduction, like every 3 minutes it deducts all these things. These are more advanced thing. I'm not going to get into that, but each spec, each destination rule, where you can go write all these things, your timeouts, your failures, your retries, your mirroring, and the advanced thing using user agents, where we did all those things. Everything could be done there. Okay, that's a destination rule. And when we have one gateway, basically the customer gateway, so which is basically, it's again a virtual service which says that how the traffic has to enter. That's what you saw on these things, right, where I was curling this one. As you saw my URL right here, I'm just doing a curl there, right, to the Istio, because all the traffic has to go through Istio gateway so that you get all these capabilities baked inside your service. All right, I think that's pretty much I have. So let me go see my slides to see if I have anything else to share. Okay, obviously I need to share you guys with the book thing, right? So probably once you get the slides has resources thing. So if you go to the developers.redhat.com, okay, I'm just going to go to that one right now, developers.redhat.com. Okay, these are part of the resource thing. I'm just going to put that on the chat. I'll request Tanya to put this one also there. So you should see the ebook section on this chat. I mean, on the site, go register yourself here. So if you go register yourself here, so you should find the ebook size down below. You should see all the ebooks here. These are all free to download. There should be an Istio one also. When you click view all ebooks, I'm just pasting this thing on the chat. I think I request Tanya, or you want to paste this one back on the chat so that people can get it. And you have lots of ebooks here. These are all free ebook downloads. Free ebook downloads for you guys. You can just go register yourself at developers.data.com and you get it. And you should have one for Istio here. Okay. So and then you can just use this one, and then you have other things. You have service mesh, serverless, everything right there. You can just register yourself, download it from there, and we keep adding all our books to this particular thing, and then you can just get it downloaded from there as well. Okay, and with that, I should say that's pretty much I have. I think probably you'll be getting the slides which I used as part of this thing. If you have any questions, as I said earlier, I'm just going to flash my social handles again so that you can kind of get back to me on the social handle here. Okay, and I think we have 5 more minutes. I'll try to see if we have any questions. Otherwise we are good to go. Okay, so any questions again, offline, if you want to discuss more anything specific, drop me a note. Obviously you can go to the tutorial link which you already pasted on the chat. You can just go to the tutorial, and then if you have any questions running the tutorial, open up an issue for us. We'll be happy to answer those questions as well. Okay, so with that, so probably I would, if there is, I'll wait for a few seconds to see if there's any questions on the chat. If there is no questions, then probably I can sign off, saying goodbye. And wherever you have, be take care and be safe. I'll catch you up in another session sometime soon.